Welcome to my idea-based research narrated slideshow on the general topic that girls are underrepresented in computer science education. So the central problem that girls are underrepresented in computer science education will, in this slideshow, look at the operational definitions behind the research, the hypothesis for the research, the literature review, the research methodology, research design, data collection, procedure, and expected results, and then a short conclusion. First, I'm going to operationalize many of the definitions used throughout this presentation, including all four of my dependent variables. The first dependent variable, current computer science knowledge, I will operationalize as showing an aptitude in basic introductory computer science from the framework, from the first level of the Manitoba Computer Science Framework curriculum. This will be measured with informal quizzes administered by the club leaders and examining quiz scores during club events. The second dependent variable, current interest in computer science, I will operationalize as the survey responses to questions around interest. This will be measured using an online tool very much like the Computer Attitude Questionnaire, or the CAQ, with questions that specifically get tailored around computer science. The third dependent variable, current comfort level working in computer science, will also be operationalized in the same way to survey responses around comfort level in that subject area. Measurement again using that standardized questionnaire again. The fourth and final dependent variable, the current likelihood of registering for high school computer science courses, I will operationalize as an increase in the number of female students enrolled in grade 9 to 12 computer science courses compared to historical data of the previous year enrollment, and that will be tracked through Power School enrollment data, as seen here. Other words to operationalize, the term coding club, which will be used, describes a group which does activities with the expectation of having a fun theme towards learning computer science fundamentals, and will have specific activities structured within that club. The phrase mentor is used in this presentation. I will operationalize as a student peer close in age 1 to 4 years of the same identified gender as the student. And when using this as a verb, the term mentoring will mean that the mentor participates in the leadership activities and guiding the students in the group. Moving on to my second part of the slideshow, the research hypothesis. So the basic idea behind the research, the underrepresentation of women in computer science, as you can see by my citations there, has been already researched a lot and has led to a research hypothesis that I adapted from my IBR position paper, and I will state as participation in a female mentored coding club program will lead to increased enrollment in high school computer science courses by all girls attending one of the middle schools in the St. James School Division. This hypothesis certainly isolates girls, but this is not to minimize the underrepresentation of other alternative gender identities or indigenous heritages or socioeconomic statuses. It is meant to be girls supportive of this particular gender inequity, which you will see I highlight in the literature review. This does not mean that research could be expanded into some of the other areas from above, but again, it's creating a girl-supportive research environment. And that you will see, as I hope I will show through the literature review, that by increasing a female presence in the computer science classroom, it will lead to lots of learning objectives, to things like overall performance and acceptance of this subject area in an area that is largely underrepresented by girls. Okay, so in my literature review, I'm going to set up what I like to call a theoretical framework, starting with the need for computer science education. As you can see by my citation there, that computer science education in the education field is growing in need throughout North America and the world overall. Then from there, I'm going to move my need to the importance of public and private schools recognizing computer science as a core 21st century discipline. Having schools and school divisions recognize that computer science is as important as traditional sciences like physics and chemistry and biology. Then, as you can see by my citation, moving from need and importance to gender, recognizing that a gender disparity has occurred in computer science courses and that needs to be addressed from an educational standpoint. Then moving from gender to belonging, in addressing that gender disparity, my citation shows that when we increase girls' interest in enrolling in computer science, we can also look at their sense of belonging in that program. And then from there, I've moved my thought or my sort of chain of research ideas to the idea of mentorship, which you can see again in my citation there. That this idea of an all-female cohort could establish that sense of belonging, which could address the concept of gender, leading again to how important this is and the need overall in the education industry. Okay, so that is where my literature review led me, from the idea of computer science in general to finally the idea of a female mentorship approach. You can see a citation here from code.org that as the number of female students increase in computer science, it correlates with all kinds of things that would help in that industry. Moving on to our methodology, the participants of this study would fall into two categories, a student population and a mentor population. All participation is voluntary. All sampling will be from the 6 middle schools and the 5 high schools in the St. James School Division. All these participants would be minors. The mentor population would be drawn from girls who have taken computer science courses in high school, utilizing their prior knowledge, whereas the student population will be drawn from promoting it and mentor group presentations promoting it to the middle school information technology, sometimes called tech classes, which draws upon an already existing interest in technology. And then tech teachers in the middle schools will be given a sign-up sheet for the girls to indicate that they'd be interested in participating in the research. The mentor group would also have a sign-up sheet in the high school classes. And then once both groups have committed and signed up, permission forms from parents, consent forms from the division and school administration would be obtained. So looking at the chart I presented here, the mentor group would be a grade 11 or 12 level, whereas the student group would be a grade 7 or 8 level. Prerequisites for the mentor group would be that they have taken some computer science courses or currently taking them prior. And with the student group, there isn't really any prerequisite, but that they would be taking an information or tech class, which is a requirement of middle school students. For the mentor group, their prior knowledge would be that they have studied the concepts of computer science before, whereas the student group would have no prior knowledge prerequisites. The motivations of the mentor group would be to inspire their peers, and for the student group, it would be just a general interest in technology and possibly computer science in general. So the materials for the study would be an active computer lab at the middle schools and or high schools to conduct the coding clubs. From a software perspective and from a material perspective, they'd need interactive whiteboards, projectors, maybe paper marker. The software, all software would be free, including Microsoft's Visual Studio, Apache NetBeans, a viable internet browser, Google Chrome is suggested, and the Power School portal, which again is part of the St. James School Division currently. The study will use a correlational design, as you can see from my citation. The hypothesis, again, is that the mentorship will increase both interest and likelihood of enrollment. The independent variable, the participation in the coding clubs by the mentors, and the dependent variable is the level of interest and female enrollment rates in the high school computer science courses. Now, that's a general description. The instrumentation will use an online survey to fill out, like the CAQ described earlier in the definition of terms. But in more specifics, we're going to look at 4 dependent variables from the student group. 1, the current computer science knowledge. 2, the current interest in computer science. 3, the current comfort level working in computer science. And 4, the current likelihood of registering for high school computer science courses. So the survey instruments will be done in a pre-test format prior to the first meeting of the coding club. then an immediate post-test after completing the last session of the coding club, and then finally a delayed post-test approximately 6 weeks after the last session of the coding club. The survey data, again, will use that online administered instrument through a web page using what was described earlier. The Power School historical data will be used to measure enrollment rates, and this will then get calculated to look at whether or not the scores have established a gain. And again, you can see some citations there on this. So the procedure for this research would be that the mentor group chosen first would attend 3 one-hour training sessions to learn a curriculum of activities to deliver in the clubs and be encouraged to share their own experiences as a female taking computer science. Then they will be given a short presentation to be given to the middle schools to promote the idea of joining a coding club. Once the student group has been chosen and the first session of the coding club begins, the pre-test will be administered before the first session begins. Then the club will run for 5 weeks, twice a week, for 1-hour sessions in the morning, at lunch, or after school, for a total of 10 hours of mentoring. On the last session of the final week of the club, the student group will take a post-test as a comparative instrument, and then a 6-week interval will pass, and then the tech teacher at the middle school will administer the delayed post-test for the final time. And these 3 data points will be used to analyze the change in the 4 dependent variables. Finally, the expected results of this research would be to show statistically significant gain in all 4 variables between pre-test, immediate post-test, and then the delayed post-test. Possible drop-off between the immediate and the delayed. In the first dependent variable, it's expected that mentors who have been taught computer science will obviously report a gain in that knowledge, that they will report this, and we will see that in their test results. The second dependent variable also will show a significant gain, it's hypothesized, because the enthusiasm of the mentorship program will transfer over to the students and will be reported. The third dependent variable, again, by feeling a sense of belonging and the gender homogeneity, will create a significant gain in the third dependent variable. And finally, in the fourth dependent variable, it is expected that I will see significant increase in registration for high school computer courses through the Power School data. In conclusion, the basic idea that girls are underrepresented in computer science education, and more specifically the hypothesis that participation in a female mentored coding program will lead to increased enrollment in high school computer science courses by all girls attending one of the high schools in the St. James School Division is now clear. That this research will track the effect of the encouragement of female mentorship of girls of the same age, and will show statistically significant effect on that enrollment level and subsequently other educational byproducts. You can see that this is supported by a lot of the research done by organizations like CONT'D, where women who tried computer science in high school are 10 times more likely to major in it. And this leads to, again, more citations from me from the University of Ottawa research, as well as my own experience as a 20-year plus computer science teacher, that the encouragement of females is crucial. And as a final note, if we do not address this, it could take more than a century to reach balanced representation of females in the computer science classroom. This representation here, this citation from code.org, shows that it would take till 2145 to represent that balanced representation. Thank you for watching. Following this, you can certainly see my sources in the rest of the